just a second. There we go. Okay, so today, we're going to talk a little bit about the new .NET, specifically .NET on Mac, and we're going to introduce Docker. So there's been a lot of flux in the .NET world over the past couple years. To me, there's nothing more uncomfortable than working on a Mac. I know I have a MacBook. That was not my choice. That was a business decision. So getting used to the Mac, getting used to doing everything on the Mac has been a bit of a challenge and interesting to me. Microsoft has decided that they want to go ahead and support .NET on the Mac. They also want to support it on Linux and a few other things. We're going to dive into a little bit of the reasons as to why. We're going to talk about these technologies, what I use, and this is going to be kind of a high-level introduction. I don't want to go into a whole lot of detail. This can get complicated pretty quickly, especially when it comes to deploying to Azure, deploying to the cloud, and things like that. So, excuse me. So we're going to start. I'm going to kind of introduce a few things. First, a little bit about me. I'm the Director of Engineering at Concierge. Previous to that, I was a full-stack .NET developer. I still write code pretty often, but nowhere near as often as I used to. I have my CS degree from Oregon State. My Twitter handle at Danny W. Burrows. I don't tweet very often, but I will probably stalk you if you tweet at me, so just be warned. My GitHub, I've got some projects up on GitHub. My last talk I did was about Elasticsearch and .NET. That is still up there. And I have a few other projects up there. Nothing super interesting, but you can always poke through and just kind of take a look at what I do. So I want to jump in and talk a little bit about Microsoft and why they decided to bring .NET into Macintosh. So it's about 2 years ago, Microsoft went ahead and open sourced .NET. I know when this happened, this was a huge thing in the realm of C# and .NET programming. I was super interested in this and a lot of reasons why they're doing that. That's when they also introduced Visual Studio Code, which I'm going to show here as well and talk a little bit about. But there has been a lot of question as to why Microsoft is doing this. Microsoft has traditionally been a very locked down technology. Everything to do with Windows and programming in .NET has always been, in my opinion, very cost prohibitive. So why would Microsoft all of a sudden decide to take the step of making this open source? Well, a couple reasons, and I've got a few of them listed here. The first one is Azure. Microsoft is really, really trying to compete with Amazon and Google and DigitalOcean and some of those other large cloud companies that are out there. And Azure is Microsoft's tool to do that. They're really trying to put effort into driving business and enterprises to use the Azure cloud platform. We use it at my work. Everything we do is hosted on Azure. I think it's really flexible, but it's also traditionally not been as robust as like an AWS has been. So Microsoft realizes that in order to see long-term growth, to see the long-term plan, they're going to need to invest heavily in Azure, and open source and .NET to get it working on Mac and Linux was step number one to do that. One of the other things is I think they're really looking to leverage the open source community. I mean, if you can crowdsource your bugs, why not? I would love to do that, but, you know. So, if you take a look at the .NET repositories that are on GitHub, there are tons of open issues. There's a lot of community feedback. There's a lot of pull requests being open, reviewed. I mean, there's a lot of collaborative effort going on. And I think Microsoft was really looking to take their software to the next level, to take .NET to the next level. I think that's really what they were looking to do there. Another big one, I think the next couple all kind of go hand in hand. As a .NET developer, Node.js has completely disrupted server-side programming. It's being used in all kinds of code camps and hacker camps, and schools are starting to use it because it's free. It's fairly easy to get up and running, and Microsoft has traditionally been, again, kind of cost prohibitive as a barrier of entry. I mean, just look at an MSDN license, right? Somebody that's just wanting to learn how to code isn't going to be able to fork over all the money that it would traditionally take to get up and running. So I think open sourcing it, starting to support Linux, starting to support Macintosh, Microsoft really made an effort to bring try to solve all these problems all at the same time is really what it boiled down to. So from there, let's talk a little bit about Docker. I'm going to introduce Docker as a part of this conversation in this talk. So what is Docker? I don't know, does anybody actually use Docker in production or on their systems here in the wild? One, and I got a maybe over here. So yeah, it's still pretty new to the .NET world, right? This is something, Docker's been around for 4 or 5 years at this point. There's a whole history about containers and Docker being, one of the leading edges in building containers. So Docker is a company. What Docker does is they basically wrote the engine for containers, and there's a whole infrastructure around this. There's Docker Hub where you can actually put up all of your containers. You can make them public, you can make them private, just kind of like GitHub. But what containers are at a core, and this is a very high level, so if you guys know a lot more about this, don't grill me over this one. But it's a self-contained executable package of software. Basically, everything for running your software is contained within the container. It's isolated. It's its own little system. You can think about it like a virtual machine, like it's just a little packaged up virtual machine that doesn't quite do it justice. But it would be essentially like having a multitude of small little virtual machines that all communicate with each other on your device, on your server, anything like that. So, but I do want to stress it is not a VM. It's not a full-fleshed VM. Everything inside the container contains everything you need to run the code, everything you need to actually build your software, run your software, and deploy your software. So why Docker, and why am I talking about Docker, and why does Microsoft care about Docker? Because we'll go into this in a little more detail here in a little bit when we get to some of the code. So the big thing is scalability. If you can put something in a container, once you have an isolated, reproducible environment, it's real easy to scale out, right? Horizontal scaling is now a solved problem. All you need to figure out is load balancing, and they actually have tools for that. There are orchestration tools that allow you to auto-scale. They load balance, they can spin up new services, spin down services, all with just a couple clicks of a button where you can set up rules to do this on your own. It's horizontal. If you need more throughput, like in an API, you just add another container, right? It's pretty simple, pretty straightforward, and very scalable. It's isolated. So when you are working with your Docker containers, it is its own, essentially, if you think about it as its own little machine, kind of tying back to the virtual machine, but not virtual machine, it's isolated. External dependencies don't affect it. Everything happens within its own container. One of the big reasons that I like Docker and why I've been pushing my team to use Docker and kind of head in that direction for a while is reproducibility in development. So if Concierge, we are a web-based company. We have a lot of APIs. We got a lot of software out there running around like I think most modern companies do. It gets complex, right? You got a cache, you got a database, you've got your servers, you got all these microservices, right? And when you're trying to develop against any specific piece, you need all of the pieces for this to work really well. How are you going to track down a bug if you don't have a reproducible system, right? This is a fundamental problem of, in my opinion, a modern day development. So being able to quickly replicate an entire system, right? Here's your Docker file, here's your DrCompose file. Here's your system, here's how it's deployed, here's how it works. It's isolated, it runs on your machine. You can host it, in Azure, you can host it on an on-prem machine. You have the flexibility to do it. So super useful. I think it's been really helpful in tracking down issues and figuring out scalability problems and things like that. The other big one, and this is kind of an interesting one for me for .NET, is continuous deployment and integration. Build servers, build scripts, things like that for .NET have traditionally required some sort of Windows environment, which has been a little bit of a challenge to solve with tools like Jenkins, right? Jenkins is hosted in a Linux environment. It's very difficult to get that to work in a Windows environment as well. So Microsoft, by kind of, by adopting this technology and by really focusing and putting effort on this, they've kind of opened the door on some of these tools. once you remove the dependency on Windows, you kind of open a lot of doors, right? Your Jenkins now works, your continuous integration, your unit tests, everything can be done from the command line, which is traditionally how these tools have been used. So because of this, Microsoft has put a lot of effort into making Docker work with .NET, with the new .NET Core. There's tools that they built into Visual Studio and Visual Studio Code. In fact, if you download Microsoft 27 or Visual Studio 2017, you can Dockerize, is what they call it, your application once you create a new application. So they're building this support in firsthand, making it a first-class citizen inside the ecosystem, which I don't know about you guys, it was not originally a Microsoft idea, so this is taking some getting used to. All right, so you're not sold. I wasn't sold. What do we do? What do we need? For the talk, I'm going to give kind of an overview about each of the pieces and show you how we actually go about doing this in the wild. So what I currently have on my machine, I've installed .NET Core 2.0. If you're not on it, I highly suggest it. Some big performance improvements over 1.0. They've extended the library by about 16,000 or so methods. So they've brought a lot more of the old C# standard library into the modern day Linux, Unix, Mac, Windows environment. I downloaded Docker, the current edition. This is actually the community edition that I'm running on my machine locally. Docker Hub, I have a subscription to Docker Hub. I have downloaded Visual Studio Code, and I've specifically installed an extension here called VS Code for Docker, or Docker for VS Code. Basically, it's a couple helper methods that are installed into Visual Studio Code to make this work. And then the other thing I have an Azure account, and I did spin up a Ubuntu VM before the talk. So that's up and running out in the wild currently. I did explore go ahead and doing an Azure Service Container, which is like their whole orchestration engine and everything like that. It's a bit complicated, and I felt that I could have spent probably 2 hours talking about it. So I'm actually going to save the more native implementation for a later date and time. But I'm going to show you how to get it up and running today in Azure. So the first thing I want to talk about, I'm primarily a full stack developer, which means I spend most of my time on the web building APIs and things like that. So we're going to start with that. I'm going to show you how to build a web app, how to run a web app, and do all this inside of Mac. So to start with, .NET has, Microsoft has added .NET CLI. So what you see here is just a quick screenshot of the project that I've used for this talk, the commands that I've run here in order to get this all to work. It's pretty straightforward. So because I'm using Visual Studio Code, I decided to do most of this building, most of the prototyping and everything from the command line. Now, Microsoft did release Visual Studio for Mac. It's, in my opinion, still beta. I've found some issues in just kind of using it in the day-to-day. And transferring over projects from like a Windows to the Mac isn't quite fleshed out just yet. So I decided to kind of keep it simple, just using the .NET CLI. This comes included when you install the framework from this website here, which is actually directly on GitHub. So once I'm done, I'm going to go ahead and post the slides on the meetup.com website, so you can go on, you can navigate to it, look at the slides, go look at the downloads, everything like that. There's not a lot of code in this talk, so I don't have a GitHub repo, but if anybody's interested, I can help out, write a README or anything like that. So a couple of the big commands, .NET New, you can prototype, scaffold out kind of your basic projects. I did a web API project. Over here on the right, you see kind of your standard methods, right? You've got your startup, you've got your program, you've got your app settings, just kind of a standard .NET Core application. .NET Build, .NET Run, those do pretty much what you think it would do. Compiles the application into a DLL, which sits on the Mac, which is really weird for me, to go and look inside of a Mac file and see a DLL. It's still working on that one. .NET Run, that basically just takes your default configuration settings, runs your API, exposes it on port 5000. Pretty straightforward. The last one I point out here, .NET Restore. So there's full NuGet dependencies and full NuGet support inside of Mac. Your libraries have to be up to date. They have to be written for .NET Core 1 or 2. But NuGet's pretty good about letting you know whether that's actually the case or not. So those are a couple of the important commands. And I'm going to go ahead and show you a quick example of all of this. So what I've got here, so currently this is running on my Mac, which is super weird. And this is just your standard controller, right? So this is the values controller. Any new .NET Core application that you start, whether in Visual Studio Code or in Visual Studio Community Edition for Mac, this is your default, right? You hit that new solution, you get your project, etc. So it's all just built here. And the way that you actually run this, let's see if I can make this bigger so everybody can see. It's pretty straightforward. It's just going to be .NET new, pass it a web API, give it a name, and quickly scaffolds out your application, and there you go. You've got your controller methods, you've got your app settings. It's pretty simple, pretty straightforward to get up and running. Once there, you basically write a .NET application. It's all the same syntax. I mean, it's all the C#. It's everything we're used to, everything that we typically do in Visual Studio. It's just now on the Mac side, which is kind of cool. So one of the reasons I like Visual Studio Code, number one, it's got the same key bindings as Sublime, which I really like. But number two, it's got everything built in, right? So all of my compilation, all my builds, all of my syntax highlighting, you know, if I wanted to do create a list, right? Like my autocomplete, everything that I would normally be used to inside of Visual Studio is here in code. So I'm not going to spend a lot of this talk about VS Code. I do really like it. If you are looking to get introduced into .NET programming either on Mac or Linux, I highly recommend it. I've actually given a talk about code in the past. I'm a huge fan. So moving from there, you have a few tools. You've got source control integration. So if I have GitHub, if I have TFS, this actually integrates directly into VS Code. But the big one for me is going to be debugging, right? One of the major problems with some of the other technologies out there, if you write Ruby on Rails, you'll come across this. If you write Node, debugging is always a little bit of a problem, right? You have to install other tools, or you have to do it kind of old school on the command line. A lot of console.logs if you're in the Node world. It's built in. So if I decided to run this, you know, I could set my breakpoints like I would, you know, any other Visual Studio project. I can run this and it will hit my breakpoints. So all the build scripts, everything is built into Visual Studio Code. As you see, you get that wonderful orange bar, which if you do this, here we go, debug, pretty simple, straightforward. So the good news is I've done pretty much nothing to this application except scaffold it out a new application. .NET new web API, give it a name, set a breakpoint, hit build and run. Pretty straightforward. There's nothing that I've done kind of crazy at this point. You can also do this from the command line. So if I wanted to go ahead and build, I can just go ahead and run .NET build. And we're going to go ahead and compile, make sure there are no errors, warnings, etc. If I want to go ahead and run, I can go ahead and .NET run, and this will run on the default port of 5000. So if I go back to my browser, and I hit that guy, there we go. Make that a little bigger so everybody can see. So, nothing super complicated, nothing super strange. I don't think there's any surprises here other than the fact that this actually works. So, cool. From there, give me just a second. All right, so that's our code example. From there, let's talk about the containers. So scaffolding out a new web API and getting it to run, it's pretty straightforward. Take you a couple minutes, follow the instructions, follow the commands, pretty straightforward. Now we need to Dockerize it, right? So the first thing that I want to talk about is, what does Dockerize it even mean? Well, normally when you just build, you end up with your bin and object files or folders. So these are pretty standard to us, anybody that does this on a regular basis. If you follow this, you're going to see you have your DLL file, right? Now, because this is a DLL file, you can deploy this like you normally would. If you want to host an IIS, you can do that. If you really aren't liking yourself and you have an Nginx or anything else that's not IIS, you can run your DLL file. But that's not quite enough for what Microsoft's trying to do. Just being able to get the DLL file and compile it, step one. Step two is really going to be, how do I scale this? How do I build this out? And how do I deploy this out into the wild? This is where Docker really comes in. So the first thing that we have to do in order to enable Docker in Visual Studio Code is, like I mentioned earlier, install the extension. I've actually got quite a few installed, but Docker. So it's this guy here. It's pretty simple. It's used quite a bit, 1.2 million downloads. Pretty straightforward. And what it does, it gives us a couple commands. So the first thing it's going to do is it's going to add a Docker file and a DrCompose file, and I'll talk about these separately. But it gives me all my commands here. And one of the things you can do on a project that hasn't been enabled is you add your Docker files. So that adds this guy, which is a Docker file. This is a set of instructions for how to build the container, how to build the image. This information, there's nothing complicated in here as of yet. It's just, if you think about it like a script that is responsible for building the image, that's pretty much what we have here. It will compile the DLL, and then it will go ahead and make a container for it. The next thing it adds is what this guy is called. This is a DrCompose file. I'll give you some more details about this, but this is a file that not only builds your container, it actually runs your container, so you can go ahead and test everything there. So as far as the Docker file, build the image, conventions allow. I apparently missed something. Don't do this when you're really tired. DrCompose, I'm going to skip the conventions. Convention, basically, every Docker file is going to be similar to pretty much every other script. There's instructions, so you've got a convention to put your instructions in uppercase. Any files, any libraries, any dependencies are going to be in lowercase. That's what that bullet point was supposed to be. Sorry. So the DrCompose builds and runs. The big thing with DrCompose is this easily allows multi-container solutions. So when you actually get this out in the wild, right, you've got a database, you've got your cache, you've got any services. If you have a service bus like Kafka or something, there are containers that host all of these that are all currently available on Docker Hub. What you can do is you build your DrCompose file, add all of those services, add all of those containers, and now you have a completely replicatable system that all you have to do to get it up and running, give somebody your DrCompose file, run a quick command to DrCompose up, and it will actually build everything, bootstrap it, get it running on your machine. It's pretty cool. But the big thing I want to point out there again, I think it's incredibly useful for development. It's also incredibly useful for testing. So those lovely QAs that are always struggling to make sure they get good environments and good data and things like that. Well, now you can quickly and easily reproduce your entire system. You give that to them, teach them how to run a few commands, and they have their own isolated system. The benefit to that, in my opinion, is huge. Not to mention, from a development standpoint, I have a lot of mobile developers on my team, and we do a lot of work on the API. It's up and down, and things are changing. So if you want some semblance of stability, you can go ahead and build all of these things inside a Docker container, give that to them, let them develop against that. It's pretty cool, makes things a little bit easier to do. But again, the entire infrastructure is deployed inside the containers, and it's isolated from the rest of the system. So as far as the Docker command line interface, it's pretty robust. There's a lot of features to Docker. I'm barely scratching the surface on what you can do, but there's a few commands that we're going to be running. The first is going to be a build. So Docker itself, the command line entry point is just Docker, and you can look through all of that. Build is going to build your container. We've got a couple flags here to clean up some things when we're done, and then we're going to tag the specific container that we're working with this tag .NET_Mac latest. So this will give you basically we're going to build a container. We're going to say this is going to be the latest version of the container. This is what we want you to use. From there, we're going to go ahead and Docker run this container. -D is detached because this is almost like a virtual machine. You can actually attach the container. You can SSH into it. You can connect into it. You can run commands. You can look at the container in its own isolated environment. In our case, we're going to run it detached, which just basically means I want to run it. It's going to be a service that's just going to run in the background, and I'm not going to have to worry about it. Ports, anytime that you're doing anything with Docker, you're going to have a lot of ports. You need to make sure ports are exposed inside of the container so you can go ahead and access it outside of the container. This would be very similar to like port forwarding on a virtual machine, right? I want port 8888 to go to my Windows VM. It's very, very similar idea. So that's going to run our image. And then I'm going to run a quick command just to verify that this is actually working the way that we expect it to. Now, on this, I want to, because I'm going to show all of this here in just a second. With this localhost, I want to point out that this is basically port 80. And if you were paying attention to the Visual Studio Code build and the .NET run, it actually exposes on port 5000, right? So there's a little bit of a difference here. Because they're not the same, right? There's running it locally, and then there's running it inside the container. And once we actually get it into the container, this is basically a deployed solution. This would be very similar to what you would go ahead and put out into production or into test or into the wild. So I'm going to go ahead and run a couple of these, just so you guys everybody can see this. So the first thing I want to do, just to kind of highlight this point, I don't have anything running right now, but I'm going to make a quick call to this guy. So I've got nothing running on 5000, and make sure I've got nothing running on port 80. So everything is currently turned off. So the first thing I'm going to do is I'm going to go ahead and build Docker, build RM, we're going to tag Mac latest. I normally don't do this part on the command line, so I'm going to go back and forth a little bit. Sorry about that. So this is the part where this is actually going to go ahead and build out the Docker image itself. We're going to tag it with .NET Mac latest. And you see here, as it kind of scrolls up, I've got this .NET Mac DLL that is now exposed. And if I want to take a look at this, I can look at my images, if I do this correctly. Images list, Docker containers list. Okay, so I currently do not have anything running. I don't have any images that are ready to go, so I need to go ahead and spin this guy up. So I'm going to run port 8080. And I'm going to do .NET Mac latest. All right, so take a look at this. So what this is telling me, this is a Docker interface on the command line that is telling me that I currently am now running the .NET Mac latest, which is the web application that we currently have, is currently running, and it has exposed port 80 to the local port 80. So now, if I go back up and run this guy, I get my values. So what this is doing is basically the Docker container is currently running on my machine, serving out those values. Now, if I go ahead and say .NET run, bigger, okay. Values, okay, so here is the current DLL that is compiled from my solution. Here is the DLL that is running inside of my container, was over here. And I want to highlight a difference real quick. So if I'm going to go back to the values controller, I'm just going to add a value up here real quick. This is super complicated code right there. So I'm going to go ahead and .NET run. It's going to rebuild my DLL. So if I go to 5,000, I've added the value 5. So we can see that update. But something that's, in my opinion, threw me the first time that I did this, my Docker container is still showing value 4 as the last. So it's basically running the last known image that used the DLL that I compiled it with, right? So anytime that we have an update, we're going to have to rebuild the image, we're going to have to publish the image, we're going to have to push it out, etc. This is pretty well known. I mean, this would be the same thing as building your application in release, copying over your DLLs, deploying that solution. So at a core, at the base, this is Docker. This is how you Dockerize an application. So from here, let's go ahead and talk about Docker Hub, because Docker Hub is really where this starts to get kind of interesting. It's literally just hub.docker.com. There are tons of images. I think at last count there were 500,000 and growing every single day. So talk a little bit about that. The things that you need to do, Docker has everything you need kind of built into it on the command line. The first thing we need to do is we need to log into Docker Hub. You need to tag your container with a specific tag that you have online that matches the repository online, and then you just need to push it. And once it's pushed, you can go ahead and pull it down onto any environment, right? So it's pretty straightforward. I'm going to go ahead and show you real quick how to do that. So let me make sure I'm logged in. Anybody use LastPass? I love it. Okay. All right, so now I'm currently logged in. I'm going to go ahead and actually run a new build of this Docker container. And I'm going to use my Docker username and my container name. So what we're doing now is we are recompiling this image. It's going to have that small change I add with the value 5 at the end of that list of strings. So now I've got it built. It is tagged as my Docker Hub username and my container name, and then which version I'm running on. Now, one of the things that I don't really talk a whole lot about in this talk, but it's kind of cool, you can specify specific versions of a container. So if you don't want to be on the bleeding edge, or if you need to lock down your dependencies, which if you're .NET developers, I'm sure you've had to do in the past, you can do that. And you can specify all of that detail inside your DrCompose file. All right, so now that that's built, I'm going to go ahead and push it. And I'm going to push Burrows. Mac. So, and depending on the traffic, this might actually take just a second. Okay, so I push this up to Docker Hub. So if I go ahead and sign in here, I can see I've got my image. Let me make this a little bigger so everybody can actually see. It tells me how to pull it, any descriptions, a short description, full description, Obviously, I'm super verbose with these things, so you got all your info there. You can check your tags. The only one I have is latest right now. It's the only one I've pushed, but you can tag specific versions. You can see I just updated it just a few seconds ago, right? So the container is currently up to date, has been pushed up to Docker Hub. Now I can do something with it, right? This is public, so anybody can go online, they can download it. I don't know why they would, but you're more than welcome to. Now I can go ahead and do things with it. And that's where we get to running in Azure, right? So when I first started this talk, I went ahead and spun up an Azure service, container service, which requires an orchestration engine, Kubernetes or Swarm or something along those lines that's responsible for managing containers and handling scalability. It got very complicated very quickly. So what I decided to do in the interest of time and complexity was just scale it back a little bit. So I spun up a Ubuntu VM virtual machine. I'm already SSH'd into it. I can log on to that. I can pull down that container that's a public container in this case, and I can go ahead and run it and show you how this is all working. So a couple notes about Azure Virtual Machine. It's literally just somebody else's computer sitting in a warehouse in central US. Before this talk, I've connected to it and I've installed Docker, make sure Docker is up and running. I've made sure I was logged into Docker Hub, and I had pulled the last image and started the service before the talk. Now that we pushed up a new build, I'm going to go ahead and pull it down and we're going to take a look at that. So a couple things about Docker and the virtual machine. It's all the same commands. Docker stop and remove the container. So basically the service itself will stop while I do an update. I'm going to go ahead and remove the container. I'll pull a new container and then run the updated container that I have. So we're going to go ahead and take a look at that. So here I am logged into my machine. Okay, and I'm logged in the Docker, and I'm going to look at what I have currently running. So what we see here is a container that I deployed last night, that was 18 hours ago, that is currently up and running, and the container itself installed on this machine is exposing port 80 on the machine to port 80 inside the Docker container. Inside of Azure Portal, I have a few things set up and running here. But one of the things I want to just quickly call out is the public IP address. So that's just the address. I didn't put any domain names or anything like that. That's pretty easy to do, but I wasn't really concerned about it. And then here, I basically take that IP address, hit my API, and I get some values. So this is going to look very similar to what we had, but I want to show you kind of quickly how easy this is to go ahead and update. So I'm going to go back to my virtual machine. I'm going to go ahead and Docker stop this container. I'm going to remove this container. I will remove this container. List. There we go. Oh, okay. We're good. All right, so I'm going to go ahead and pull my latest container that I just pushed. All right, and now I want to go ahead and run it. So I'm going to run it in detached mode. I'm going to expose port 80 on the container to port 80 on my machine, and I'm going to run my latest container. All right, so if I do Docker PS, I should have this again. See, it was spun up, started working 2 seconds ago. And if I go back into the website where I was calling this method, I run it, and I've updated. So, pretty simple-ish once you actually know how it works, but in programming, it's always the fun of trying to figure out how it works. That is the difficult part. So that's the Docker container that I currently have. It's deployed in the cloud. It's on a virtual machine. running pulled directly from what I have in Docker Hub. So from there, talk a little bit about what I want to do next. I really want to dive more into orchestration. Kubernetes is a Google tool. If you know anything about containers or talk to anybody about containers, you go about 2 pages in before you trip over Kubernetes. It is Google's answer to orchestration and scalability, getting everything up and running in the wild. Swarm is Docker's own container orchestration engine that does pretty much the same thing. If you're a Pluralsight member, they've got some good courses on there. I highly recommend taking a look at those. I want to explore that some more. Azure Container Services has the support for these built in. I definitely wanted to figure out how to get that all up and running, because one container, one system, one VM is pretty simple, but once you start scaling beyond that, it gets complicated pretty quick. And then explore some more on DrCompose. I think I could have a whole talk on DrCompose. I really just kind of scraped the surface of it for this talk. Beyond that, do you guys have any questions? Yes, sir.
Have you played around with any of the other container registries out there, like AWS?
So the question was if I've used any other container registries out there. No. I've looked at AWS and I've looked at Microsoft's version, but actually diving into the details, setting it up, I have not. Have you?
Well, the AWS, when you said the Azure one requires a lot of having like Kubernetes or whatever resources available. My experience with the AWS ones is a lot like Docker Hub, but private.
Okay. So
You can even use Docker login
to the AWS. Okay, so it sounds like AWS's Docker support is a little more mature, would be my guess. And that's not surprising. So this kind of ties back into the theme of the whole talk, the overarching idea that I think Microsoft realized a couple years ago that they were losing. I think everybody in this room probably knows that Amazon finally got into the black with AWS. They have a huge market share, and Microsoft sees a lot of potential there. And I think they're trying to capitalize on that. So I think their move to doing everything, and on the Mac is one example. Microsoft is really targeting Linux, right? I mean, everything in the server side in the modern web server is definitely geared towards a Linux environment. And I think Microsoft has been making a lot of efforts to capitalize on that. A little slower than I think a lot of us would like, but I think they're heading that direction. So, good question. Any other questions? None? Awesome.
Have you tried any Docker in your CI pipeline yet?
Yes, it did not go so well.
So what do you guys do?
We use Jenkins right now. In production, all of our systems are on. We're finally upgrading, but they're locked to ASP.NET 4.5. So we're kind of stuck with what we can do because we're stuck on 4.5. I can't. You have to build on a Windows environment, and that's something that I've actually been actively working towards getting my company specifically off of, because I do want to do CI and CD. I want to be able to run all my tests from the command line. I want to be able to test all those things before I go to production, right? I'm really lazy as a developer. One of the things that I think is a good trait are lazy developers, because they always find a better way to do something so they don't have to do as much work. So just personal opinion on that one. So.
I'm sure my boss's boss would like me to pitch VSTS at this point.
Check it out, VSTS. We'll do that.
If you can get your stuff in Docker, Jenkins will build
Yeah.
Jenkins plays really well with Docker.
Yes. Which that has been, that's my long game, right? Is to eventually get that kind of migrated over so we can do that. Cool. But VSTS came as a suggestion. Definitely will check it out. Cool. All right. Anything else? Anybody? Ladies, gents? All right. Thank you very much. Kimberly, do you want to?